Okay, so Rolle's theorem is actually an extension of the MVT. Okay, so the mean value theorem states that the slope of the tangent line is equal to the slope of the secant line. This is just an extension of the MVT. Okay? So, what this states, and I'm going to ask some questions once we get there, is that in Rolle's theorem, the following conditions must be met before you can even look at this. First of all, f is continuous on the closed interval. Well, that was the same thing as MVT, right? Has to be continuous on the closed interval. So that's stipulation number 1. Differentiable on the open interval. Stipulation number 2. Okay, is anything different from MVT yet? Okay, here's the last part. They are saying that if f of A is equal to f of B, then there is at least one point C on the interval such that f prime of C is equal to 0. Blah, 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 blah. There's a lot of letters there. What does this mean? Guys, can you tell me what this is another notation for? F of A is equal to f of B. What does that mean? Say one more time. Yes. If the y value for one interval is equal to the y value for the other, how do you find the slope? Go back to Algebra 1. Don't use f of A and f of B. It's y sub 2 minus y sub 1. So if those values are the same, and I get that value in the numerator, the slope is 0. Isn't that what that means? F prime of C is equal to 0? Okay, so this is the third stipulation right here. Okay, so what we would have to look at is that the y values are the same on that interval, and I'm going to show you how to do that. So basically what Rolle's theorem is saying is that we have a special case of the MVT. This is a very special case. Okay? And we're saying if our y values are equal, then there's going to be some place in that closed interval where the tangent line is horizontal, meaning that you have the slope of the tangent line equal to 0 at some x value. So if you look here, this is what we're saying. If my y values are equal, you have a horizontal tangent line somewhere on that interval. And we're going to find that c value or that x value. Does everybody understand? I'm going to show you how to do it. Same thing here. It could be in more than one spot. But the biggest piece we need to look at is, are my y values the same? Okay, so here it says verify, okay, the hypothesis of Rolle's theorem on the given interval and find all values of c in that interval that satisfy the conclusion of the theorem. Okay, so the first thing we're going to do is state our hypothesis. So for Rolle's theorem, there are 3 parts, and we need to state all 3. The first one is this function continuous over the given interval? Think about the sine of x. Is it continuous? Yes. Are there any vertical asymptotes? Okay, so this b value changes what? This is taking you back to pre-calc, guys. The coefficient of x is your b value. What does b change when you are graphing sine, cosine? The amplitude, the phase shift, the vertical shift. The period of the function, meaning how many cycles you will see between 0 and 2 pi. My coefficient is 1/2. How many am I going to see? I'm going to see half. So do you guys remember, it, depending on who taught it to you, so it would go base, max, base, min, base. You're only going to see half of that from 0 to 2 pi, so basically you'd have to open up the period of the function, which would be 4 pi. Do you guys remember that? Mm-hmm. Ooh, you're all looking at me like I'm speaking a foreign language, which is highly possible. Okay? You need to know your graphs. But either way, we know sine is continuous, right? No. Now, if it was like cosecant or secant, that'd be a different story, because there are vertical asymptotes. Okay, so we know that the function is continuous. F of x is continuous on the closed interval from pi over 2 to 3 pi over 2. Everybody good? So if this function is continuous, think about the graph. Can you differentiate? Meaning find the slope of the tangent line. Just think about the graph. tangent. Yeah, of course you can. A gazillion times, right? Okay, so then in part 2, we would say f of x is differentiable on the open interval from pi over 2 to 3 pi over 2. Okay, now, the third part is a little bit different because here these are my x values. So what we need to show is that f of pi over 2 is equal to f of 3 pi over 2, meaning the corresponding y values are the same. But you can't just state this, you have to show it, because this might not be true. Okay, so this is what you do. The function is sine of x over 2. So I'm going to plug in pi over 2, and I'm just going to plug in. I'm not going to do any simplifying, I'm just plugging in. So I've got the sine of pi over 2 is equal to the sine of 3 pi over 2 over 2. What is pi over 2 over 2? Okay, so we need to evaluate the sine of pi over 4 and verify that it is the same thing as the sine of 3 pi over 4. What's the sine of pi over 4? Square root of 2 over 2. Sine of 3 pi over 4 is located in the second quadrant. Sine is positive or negative there? Okay, square root of 2 over 2. Okay, check. This is done. So now I need to figure out where on this curve from pi over 2 to 3 pi over 2 is the secant line's slope, meaning the line that cuts through the curve on that interval, equal to the tangent, but more specifically, because my y values are the same, what's my slope going to be? 0. The slope of the secant line is going to be 0. Look, if these are my y values, does it really matter what's in the bottom? Because it's going to be the square root of 2 minus the square root of 2 in the top, 0. Slope is 0. So here's my conclusion. Okay, f prime of x is going to be equal to, okay, we need to find f prime of x. What do we have to use here to take the derivative? Yep, we got to use a chain rule. Okay, so what's the derivative of the sine of x over 2? Okay, cosine of x over 2 times 1/2. That's right. So this is 1/2 cosine of x over 2. Okay, this is the slope of the tangent line. The slope of the secant line, just so you guys can see, I'll do it over here, but because this is Rolle's theorem, these are my y values. So essentially I have the point pi over 2, square root of 2 over 2, and 3 pi over 2, square root of 2 over 2. These are my y values. When I find the slope, does it matter what's in the bottom? Unless it's 0, of course, but we know it's not, because it's 3 pi over 2 minus pi over 2. But it doesn't matter, because what's the numerator? 0. So if it's the slope of the tangent line equal to the slope of the secant line, we're going to say, okay, 1/2 cosine of x over 2 needs to be equal to 0. Basically, I'm saying, where is the slope of the tangent line 0? Yes? Did I miss something? Oh. Okay, so now I need to start solving. The first thing here is I would multiply by 2. Does that really do anything? No, not really. So we have the cosine of x over 2 is equal to 0. Okay. For those of us that have forgotten, this is a half angle. I don't know the half angle values on the unit circle, do you? I know the angles. Okay, so what we're saying is, if I said, just made a substitution, I said, all right, fine, cosine of x is equal to 0. I'm going to go back and use this in just a second. This is on the regular unit circle, full angles. Where is the cosine of x equal to 0? Pi over 2 and 3 pi over 2. So we're saying that x is equal to pi over 2 and x is equal to 3 pi over 2. But this right here really needs to be this. True? Yes? No? Okay. So what I have is pi over 2 is equal to x over 2. So, say again? Yeah. I heard something, but what is it? Yeah, it's just pi. We're saying x is equal to pi here. And then we have 3 pi over 2 is equal to x over 2. So what is this? 3 pi. Okay, here's the thing. These are my potential answers. Potential. I will highlight if they are my true answers. Where do I need to make sure these things are? On the interval. So, does pi fall on the interval from pi over 2 to 3 pi over 2?
Yes.
Pi does, but what does not? 3 pi does not. It's too big. So this one's out because it's not on the interval. This is my answer right here. Okay? Questions?